Okay, so we can start. I think I have made the arrangements. So I'm presenting now. Okay, so I think I am audible now.
Yes, sir.
Hmm. Okay, so as I was telling that this is from the Sketty book slide and Princeton lecture note. Okay, so we were discussing this coin changing, greedy algorithms, and in greedy algorithms, coin changing, interval scheduling, and interval partitioning we have seen. And in this interval partitioning, we had one resource. Okay? And in this interval this partitioning, we had several resources. Okay? Several resources. And in this scheduling to minimize lateness is again we are coming back to one resource. Okay? We are coming back to one resource, and we have to take some kind of clever decision that how we can proceed for executing the jobs so that our lateness we can minimize, right? So with an example, let us try to understand what is the meaning of this. Okay? So here what we are having is single resource processes one job at a time. Single resource. So that I was telling you that's single resource. Say that resource is your brain. That means you. Okay. And job J requires TJ units of processing time and is due by time DJ. In the last class, we were discussing that each job in this case, scheduling to minimize lateness, what we are having is each job is constrained by this TJ. That means TJ amount of time will be requiring to process this job. Well, whenever we are starting, TJ amount of TJ amount of processing time will be required. So if I am starting, I can start from 8 o'clock or I can start at 9 o'clock or 10 o'clock. But whenever we'll be starting, that will be requiring, say, TJ for this case, for this job, TJ is 2 hours. Okay? So if I am starting from 8 o'clock, it will be ending by 10 o'clock, right? If I am starting from 9 o'clock, then it will be ending by 11 o'clock, something like that, right? And it is due by DJ. Okay, that means a deadline is there. A deadline is there. That means you can think of these jobs as the assignments. These jobs are the assignments given by me. Okay, so assignments. Whenever I am giving assignments, I am telling that okay, that assignment will be having some deadline. That means by 9 hours you submit by 9 hours. Okay? And I know that there is an estimated processing time of each job. That means each of the assignments. So the assignment number one, that is having TJ as T1 equal to say 2 hours. But it should be completed and its D1 should be say D1 could be this 9 hours, right? And similarly for second assignments, T1 maybe 3 hours and it's T1 T2 and D2 might be say 5 hours, 5 hours, something like this. So this is the input what we are having for this algorithm. And if job J starts at time Sj, it finishes at time Fj equal to Sj plus Tj. So in the previous case, in this interval scheduling algorithm, that we had a start time and a finish time. But here, this finish time we are calculating from the start time and the processing time Tj. Okay. So whenever I am starting from that 2 hours, say for this case one, and this lateness for that job J, lateness is defined as 0, comma Fj finish time and the deadline. Okay, finish time and the deadline. So if this job J, if this job 1 is being processed fast, right? So in that case, what will be its if F1? F1 will be S1 plus T1. So that will be this this start time. Say this start time is maybe this 8 o'clock, and it is taking 2 hours of time. So it will be finishing 10 o'clock. Okay. So what will be this Fj minus Dj? Dj is 9 hours. Okay. Dj is 9 hours, right? So Dj, if this Dj is 9 hours, right? If Dj is this 9 hours, say this T1 means maybe we can think of this Sj S1 as we will start from say 0th hours or 1th hour, okay, and we'll be doing the job. So this might be okay. So this example might be clearing your doubts. Okay. So let us take this example, and then we'll be coming this lateness. Okay. So this is job Tj, and this is its deadline, right? So job 1 having 3 hours of processing time, and deadline is 6. Okay. So job 2 will be having processing time 2 hours, 2 units, and this deadline is 8. So on, and this so on. We are having job 3, 4, 5, 6. Okay. So now this say this algorithm here, whatever algorithm is proposed here, so that algorithm, we don't know yet what is the algorithm behind this. Say whatever way they are processing, let us try to understand. Then we will be proceeding systematically that which algorithm will be good. Okay. So now say this, according to this, say this job being processed fast. Okay. This job being processed fast, and it is starting from this 0th hour. Okay. 0, 0, then 1. So that will be 1 hour. Will be going by, then 2 hours will be here, then 3 hours. Okay. So on. So if it is starting from this from here, right? So this job, whenever I am taking this job number 3, I am taking first. I don't know by what logic they have taken, but let us going by this example. So this 3 is being processed fast. So now its processing time will be 1 hour. So, but its deadline is 9. Okay. So that means you are told that for this assignment number 3, you are having 1 day. 1 day is given as the processing time, and you are having the deadline. That means by say 1st March, if you are starting from this at the end of this 28th February, that means at that day. Okay. So it will be taking 1 day of time, but your deadline is by 9th March you have to submit. Okay. So if you are starting that job by this hour, and that will be requiring, say, this point of time, that will be requiring 1 day. So you see, according to this finish, you are within the deadline. You are within the deadline. Okay. So what will be your finish time at that time? Okay. Finish time will be this start time is 0, and this processing time is tj equal to 1. So that will be 0 plus 1, that means 1 finish time. And what will be this fj minus dj? So fj, so this f1 minus this d1. Okay. So this you fj
Minus
minus
8.
this, huh? Sorry, anything you are telling? Am I audible? Am I
Yes.
audible?
Minus 8, sir.
Am I audible? What you are telling? So this so this f1 minus d1 at that time, what will be this? 1 minus d1 is 9, so that will be minus 8, right? And what is the lateness here for this job whenever it is taken? So this will be maximum of 0 and minus 8. Okay. So 0 and minus 8, that will be 0. That means if I am taking this job first, then so far within its processing time, we are not delayed. Okay. Then they are taking this job. So this job number 2, which is having deadline 8. Okay. Which is having deadline 8. So now whenever I am taking this, I am seeing that its processing time is 2. Okay. 2 days, say, this assignment. So if I am starting from at the end of this day 1, and then it will be taking 1 day, and then this will be taking another day. So by third day, I will be completing this assignment as well. Assignment number 2. Okay. Assignment number 2. So what will be its processing time? So the processing time of F2, that will be, so I'm writing here F2. So that will be equal to this Sj. Sj is this 1 right now. I am starting from 1, and then 2 hours it will be taking. So 2, so it will be 3, right? So what will be this F2 minus D2? What will be this F2 minus D2? Who will be telling?
Minus 5.
So 3 minus this 8, that is minus 5. So can you tell me in this case whether we are getting delayed or not?
No, sir.
No, because that lateness for this will be calculated by this formula 0 to 0 comma this minus 5. So 0 comma minus 5, right? So that is again 0. That is the maximum. So it is, we are not, still we are not delayed. Okay. So then the job number 6, so not say this, this job number 6 they are considering. Okay. So D6 they are considering, right? So this is 15. The deadline is 15, and its processing time is 2, right? So you see, we are starting from 3, then it will be covering up to 5. And its deadline was 15, so still we are not delayed here. then they are considering D1 equal to 6. So that means the job number 1, that means assignment number 1, they are considering. Okay. So its deadline is 6, its processing time is 3. Okay. So if I am starting from this 5, then it will be taking 8. Up till 8 we can complete this. But you see, in this case, what is the finish time of this job? This I think F4. Okay. So what will be F4 in this case? I can write here because I haven't considered this alignment of this open board in this laptop. So F4 will be what? Can you tell me what will be F4?
8, sir. 8, sir.
8. So now this F4 minus this DJ here, that will be what? That means in this case, this job number 1, if I am denoting by this D1 maybe,
No.
or D4, whatever I am writing. So F4
F4.
minus D4 will be 8 minus 6. So that is 2. Okay. Now in this case, can you tell me whether we are delayed or not?
Yes, we are
Yes,
delayed.
sir.
Yes, we are delaying. We are delaying by 2 hours. So 0, comma 2, the maximum will be 2. Okay. So that will be giving the lateness. So you see here they have shown that lateness is 2, right? And accordingly, if I am considering the next job, that is D5. So this job, its deadline is 14, its processing time is 3. So if I am starting from 8, so it will be taking up till 11, right? And in this case, you see uh, its finish time is 11, and D5, its deadline is 14. So 11 minus 14, again it will be negative. So lateness will be again 0. So here we have covered something. We have covered something, right? Now they are considering this job. Okay. So its deadline is 9, but its processing time is 4. So 11 to 15 it will be taking to complete, but its deadline was 9. So how much will be the delay? So this is if right now whatever f, uh, say this f star, that is 15, and then d4 is equal to 9. So this f star minus d4, that will be 15 minus 9. So that is again the 6. So positive, right? So this maximum of 0 and 6, that will be 6. So 6 hours of lateness we are having here, right? So we are again far behind our deadline. So this is, you see, we have to, so the goal is we have to schedule all jobs to minimize the maximum lateness L. Okay. So maximum of all LJ, all lateness, whatever we are having. So you have to minimize that. So the obvious question is that, is there any other schedule which will be giving on the same input, which will be giving the minimum lateness? Okay, minimum lateness. Okay, so that we have to minimize this lateness. Okay, so how to proceed with this? So then the thing is that, okay, we are having this greedy template, right? So as we are dealing with this greedy algorithm, so this we have to schedule jobs according to some natural order, right? According to some natural order. So that will be signifying the greediness here. So the first thing is that shortest processing time first, right? Shortest processing time. So now this shortest processing time, if I am going by this shortest processing time, schedule jobs in ascending order of processing time TG. Say we have given, I have given you some assignments, okay? And then greedily you are thinking that, okay, whichever assignment having the least processing time, with that I will start, right? So if you are greedy in that sense, then whether that will be leading to the optimal solution or not, that is the question. But here one counter example is given, that if I am going by this, then it will not be, it will not be optimal. Okay, it will not be optimal. Maybe some other algorithm is there that will be optimal, right? So let us see what is happening here. So this, we are going by the processing time. Then can you tell me, out of these two jobs, which job I will be taking in this case first? If I am going by
1.
the ascending order of processing time TJ,
1.
1. So this is having least processing time, that is 1, and 1 and 10. So this definitely 1 is minimum, right? So we are going by the ascending order of processing time TJ. So now this 1 is processed. Okay. So in the previous case we had that, okay, this this will be one day it will be taking to complete the assignment. We are starting from the 0th day and 1, but its deadline was 100. Okay. So according to our previous definition of lateness, are we late here?
No, sir.
Are we late?
Sir.
Are we within the deadline?
Yes, sir.
Yes. So we are not late. Okay. So it was 100 days given for completing this job. We have completed by one day only. So we are not crossing the deadline, right? Now, if I am considering the next job, so then I think it will be taking 10 more days. And so at 11th day, we will be completing this. So in this case, F star will be 11. And what was the deadline? D star?
10.
10.
10.
Deadline was 10, right? So in this case, if F star minus D star will be 11 minus 10, so that will be, sorry, this 1. And then this maximum of this 0 and 1, so that will be 1. So lateness is 1. So the deadline here was 10 and we have completed by 11. So definitely the lateness equal to 1. Right? Lateness could have been 1. So this is maybe means if I am taking other way around, okay, if I am taking this job first, if I am taking this job first, then it is completing by 10 hours, sorry, 10 days from 0 to 10. In that case, are we having any kind of lateness?
No, sir.
No. And then I am considering this job number 1. So in that case, I'll be completing by one day. So this is 11, but the deadline was 100. Okay. So in this case also, are we in the deadline?
Yes, sir.
Yes. So lateness is 0 here.
0.
So lateness is 0. You see, it is quite interesting, right? So lateness is 0 here. So this example, this greedy template here is not the optimal one. We are having some other algorithm, some other, uh, maybe here we are going by the deadline. Okay? We are going by the deadline. In the previous case, we were going by the processing time, minimum processing time. Here we are going by the uh, minimum deadline maybe. Okay, and that is the hope that, okay, if we are going by the minimum deadline, then that might be leading to the optimal solution. Okay, as it is being shown here, the lateness is 0, but here the lateness was 1, right? And in this case, there are other examples given. If you are scheduling the jobs in ascending order of slack, dj minus the tj. Okay, dj minus tj. That means the difference between the tj and dj. Okay, and based on that, you are arranging the jobs, which job will be processed first. Okay, so based on this, they are calling that this is a slack. Okay, so based on this, if we are scheduling, then also we can create example that will be showing. So you check that whether this is leading to the optimal solution. But this example is given that if we are going by this, then also we are not being able to, we are not being able to, we are not having this optimal behavior. Okay, we are not having this optimal behavior. So again, another template maybe was there. I don't know. Maybe some other templates you might be creating. Okay, but which which template which template will be leading to the optimal solution. Okay, so here, this, as we have already seen, that if we are going by the least deadline first, least deadline, okay, least deadline, then there is a hope that, okay, we might be having some kind of optimal behavior. That means we can get some optimal result. So that means we can minimize the lateness, and that is the algorithm is shown here. Okay, that algorithm. So in the next class, we'll be seeing that algorithm. And thank you again for attending the class at this hour. So definitely, I am so happy. Okay, but again, for that lost connection, I apologize. Okay,